Alright, lightning fast here. We're going to do proofs review, getting ready for the second part of the test tomorrow. So let's go ahead and go through and try to knock these four out. Try to talk strategy a little bit as we're doing these. So step one, and to save time, I'm not going to recopy all of this stuff down, but basically you recopy all that stuff down there, and then you write given as your reason. Now, I always go through and I like to count up any congruent symbols. So I have MJ congruent to ML. Well, luckily that's already marked on my picture. So those are sides. So right now I know I have an S, and I'm looking to get one of these 5 congruence theorems to prove the two triangles are congruent. So I need 3 parts always. I have 1 part right there. Well, then I'm looking for trying to, I call it squeeze the juice out of the other clues in the given. So I have another clue here that K is the midpoint, the middle point of JL. So if K is exactly in the middle of JL, I believe that I can say, if K is in the middle, I can say that LK, segment LK, is congruent to segment JK. All right? And why? Because I know what the definition of a midpoint is. Definition of midpoint. So that gave me another S. So now I have 2 S's. So I'm looking at, it's probably going to be one of these 2, but see what else I can get. Now I'm looking for hidden things, and when I refer to hidden things, I refer to either number 1, vertical angles. Okay, I'm always looking for vertical angles. That's whenever 2 lines cross, it forms the X. Or I'm looking for a shared side, and we use what's called the reflexive property for a shared side. And that's what I'm going to do on this proof. I notice both of these triangles have a shared side. They both share side MK. So I just have to write that down. I know it sounds crazy, but I do have to state that MK is congruent to itself. And the reflexive property says I'm allowed to do that. And now when I look at my congruencies, I have 1, 2, 3 of them. I have all 3 S's. So I think it's safe to say I can now give this proof statement as my last step. Step 4, triangle MJK is congruent to triangle MLK. And that would be the side triangle congruence theorem. So pretty straightforward on that first one. Let's move ahead and check out number 2. I'll move a little bit quicker maybe through this one here. So number 2, basically you regurgitate the given, you grab all this stuff, you come down here, you say given. I notice the picture is not marked, so I do see a congruency statement. Angle A and angle B are congruent to each other, so let's mark that. So I have an A. Now, I don't know what book I stole this problem from, but this notation is weird. I've never wrote it like that in our class before, so I stole this from a test or a book that uses a little different notation, but I wouldn't write it like that. I would write this as segment AB and segment DC, because you should always use the endpoints, so I don't really like what they said there, but I can still do it. It says that segment AB bisects DC. So I know that DC, this dude, it's always whatever comes after the word bisect, he's the one that got chopped in half. So I know that DE equals EC. DE is congruent to EC, and that is definition of a bisector. So I got that marked down. So I have 2 pieces. I have an S and I have an A. So what can I get from my hidden stuff? Well, I see a pair of vertical angles right here. And to make life easier, I'm just going to call them 1 and 2. I'm going to say angle 1 is congruent to angle 2 by vertical angles. And I think I have enough now. I see another A, and the side is not between the 2 angles, so we formally write this as angle, angle, side. And I would say that triangle congruent to triangle, just copying this stuff down. I'm not going to write all those letters, but that's what it would be. Alright, moving right along, proof number 3. So I'm looking here, And what do I see? Well, I got to do my given, of course. Given, grab this crap, put it down here. Looks like I have a set of sides, ML and LK. ML and LK. Sweet, so I got a side. Well, I do see a hidden feature. I do see that JL is congruent to itself. So that's the reflexive property. So I've just added another side into the mix. Now I squeeze the juice out of my given and I see that I have some perpendicular action going on. So if JL is perpendicular to MK, I can say that angle 1 and angle 2, and I probably should say first, angle 1 and angle 2 are right angles. This is probably the formal way to do it, because that's what perpendicular means, they're right angles. And then I could probably come back and say that angle 1 is congruent to angle 2 because all right angles are congruent. I don't know if it's okay to kind of combine these into one step and just say all right angles are congruent. I probably wouldn't mark it wrong, but it's better to have more than what you need. So I now know that these dudes are right angles and they're congruent, which basically I can now use hypotenuse leg. You know, actually I could also use side angle side. So either one. This would probably be your best bet for step 5. Triangle, congruent, triangle, HL. Either one would work though. Next one, number 4. Last but not least, I'm going to bust out my given. I'm going to say, hey, all this crap right here, given. Notice that they did not give me any sides or nothing congruent. I have 0 congruent symbols yet. So I got to get all this on my own. Well, the first thing I see is I see they share a side. So I see that AD is a shared side. It's equal to itself. So we're talking the reflexive property. Again, use this one a lot. Then it says segment AD bisects or chops in half BAW. Well, where's BAW? BAW is this big angle over here, so it chops it up into 2 equal pieces. So I think I know that angle 1 is congruent to angle 2. Okay, but then also AD bisects BDW, so it also bisects over here at the other end. Now these guys are different than the blue ones, but they're equal to each other. It's almost like a kite got chopped in half. So on the same line, I'm just going to say angle 3 is congruent to angle 4. How do I know that? Because I know what the definition of an angle bisector is. You probably could have just put bisector, but I'll do definition of angle bisector just to keep it proper. And I think I do have enough now to say triangle congruent to triangle because of angle, side, angle. Alright, so that was short and sweet. Hopefully you've between the quizzes and the homework and the review and now the test, hopefully you've got your fill of proofs and you kind of start to see the flow to them. So good luck tomorrow. See you.